start with the topic electrochemistry in this session. So let's see what the electrochemistry is here. First, we will see the term energy. So what is the energy? Energy we can see in two ways. First, one is the transfer of energy, and second is the transformation of energy. So what do we see with the transfer of energy? So if let us say if I have a rod, this part is A and this part is B. If I will heat this A part, definitely the heat will transfer from A part to the B part, and B part will also get heated. So this is the transfer of energy. Second one is the transformation. Transformation, we can say, we can convert the chemical energy to the electrical energy and electrical energy to the chemical energy. This is an example of the galvanic cell, we will see later, and this is the example of the electrolytic cell. So this whole electrochemistry is based on this galvanic cell and the electronic cell here. Now let us say this, I have a beaker and it contains a solution of the copper sulfate CuSO4 aqueous, and I have a rod of zinc. This is a zinc rod which is dipped in this solution. So now this whole electrochemistry starts from the Galvani and the Volta experiment. So what does that experiment says actually? It was observed in this experiment when a rod of zinc was dipped in the solution of the copper sulfate solution, then it was observed that after some time this beaker got warm up. Second, the size of the zinc rod got decreases. Size of the zinc rod got decreases, and third one, the blue colored solution of this copper sulfate got fade up. So when this whole observation is existing here, so we can see that here zinc rod, zinc is giving the zinc plus 2 electrons, and this Cu2 plus ions, because copper sulfate is present in the 2 plus and sulfate ion in the 2 minus oxidation state here. So this Cu2 plus will accept these 2 electrons of zinc and will form copper solid here. This whole reaction is taking place here. This is basically a direct redox reaction in which zinc is losing its 2 electrons and copper here is accepting those 2 electrons and forming the copper solid here. So what will we see if we have indirect redox setup here? Let us say I have a beaker and the zinc rod is dipped in this solution of zinc sulfate. This is a zinc sulfate solution, and in another beaker we have a solution of copper sulfate, and the copper rod is dipped in this solution. So now until there is no connection in between these two beakers, no electricity or no gaining or the losing of electrons will be seen here. What will happen if I will connect this zinc rod with this copper rod here? So let us say I am connecting, this is a wire and this is a bulb here, and it is connecting to this rod. So what will we observe here? So here, as I have said, first of all, before we have seen that there was no connection and the redox setup was seen in a single beaker. Now we have zinc rod which is dipped in the zinc sulfate solution. Here zinc will again lose the electron, that is will produce zinc 2 plus ions in the 2 electrons. These electrons will be released by this zinc ion and will travel from this side to this side. Now electrons will be gained here by the Cu2 plus ions. Cu2 plus ions will accept 2 electrons and form Cu solid. Electrons will travel from this side to this side. Now what will happen? As we all know, how the electricity produced? Only when the electrons movement is there, right? So electron is moving from this side to this side. When electrons will move, electricity will be produced and we will observe that bulb will glow. Only that moment the bulb will glow when electrons, there is a presence of electrons will be observed. Now after a certain moment it was observed that for a moment only electron when traveled from this side to the another side, this bulb got glow up, but after a certain time it will not. Why? So now there can be the two reasons here. First of all, we can see that this is a solution of zinc ions, that is concentration of zinc 2 plus ions is here. All the zinc 2 plus ions is present in the solution, and we all know that there will be the electrostatic interaction between this plus and minus, and this will resist the electrons to move from this beaker side to this another beaker side, and it will resist the electron movement, and electrons will not move from this side to another side. On the other hand, here we can see that we have the sulfate ions here which is present in this solution. So now there is a negative charge on it, and also electron contains the negative charge, so there will be the repulsion in between them. Negative does not attract each other, so it will not attract and it will repel these electrons to move to this side. So now this was the reason that bulb was not glowing at that moment. So how we are going to achieve that this bulb can glow? So we can say we use a salt bridge here. So what is a salt bridge? Salt bridge is basically a U-tube shape in which a KCl or agar-agar solution is filled in this salt bridge, which allows the ions to move from one side to the another side. So this contains the Cl minus or T plus ions. This Cl minus ions will at this part will bind with zinc ions Zn2 plus and the Cl minus ions. It will form ZnCl2, and which is soluble in water. So this porous plug is here, in which there will, Cl minus ion will bind with this zinc 2 plus ions, and it will now not resist, or it will not electrostatic interaction will be there with these electrons. So we can see these Cl minus ions will bind with this zinc 2 plus ions and form ZnCl2, which is soluble in water, and now there will be no electrostatic interaction in between these electrons and this zinc 2 plus ions, and now the electrons can again move from this part to the another part, from cathode to anode or from anode to cathode. So we can see this salt bridge here is playing a major role in neutralizing the solution and also from allowing the ions to move from anode to the cathode part. So this all happens in this reaction here, and the net reaction we will see here is the zinc plus Cu2 plus, which is aqueous, because these two electrons will cancel out and the whole reaction will be this here. So this was a whole reaction which will be observed. So one thing which we will have to remember that while taking this solution, when you have a rod of Ag or Hg, we cannot use the saltage, because when Ag will bind with this Cl minus ions, it will form AgCl2, AgCl, and with HgCl forms the HgCl2. And we can see AgCl is not soluble in water, and because of this insolubility of Ag, it will block this part, and again there will be electrostatic interaction between electrons and the ions present here, and movement will be stopped and your cell will not work. So for the working of cell, these ions should be keep in mind that if we have the Ag or Hg, we cannot use. So here this whole part was about the galvanic cell.